Okay, so this is the VA PALS OSEHRA Working Group meeting for Wednesday, um, the 7th of February 2018 already, or maybe finally. And this is your usual notification that we are recording this session. I have posted a link to the playlist on YouTube in a note on our VA PALS OSEHRA blog. So if you want to watch one of the earlier ones, if you need something to help you go to sleep, then there it is. It looks like we only have the usual suspects, so no need for introductions. And the agenda, I think, is pretty much what it usually is. So, is Dom available? No, he's not on here. George, are you ready to show us something cool?
Sure.
Okay. Let me, there you go.
Okay, can you see my screen?
We can.
Great. So we demoed last time, our surrogate homepage, which lists all the patients by study ID that are on this system, and then the case review, initial case review page, which lists what forms there are for this patient, and each of the patients have an intake form and a background form now, and the navigation works. And if you press preview, you go to the form. This right now is going to the old SV form 2, but it also can go to the original LCAP form. In fact, you probably should go to this as a default. So this is the initial LCAP form, the classic LCAP classic form for this patient, for the background form, and it's active. You can fill things in, and press submit, and it will submit them and save them in the graph store. And the new news today is that we have gotten a copy. Dom has committed an early copy of his brand new background form, and it's hooked up so that we can use it on Avicenna. So here's the new background form, and if you'll notice, the fields are pre-populated. We're going to have to work on a couple. This is early. This hasn't gone through a lot of testing, but essentially, for any patient or for a new patient, you can go to the brand new format of the background form through Vista. So save, and you don't have saving working yet, because Tom's working on designing and implementing the submit buttons, or the save buttons. I think you should call them save buttons. So if you press next, it'll give the error messages. Now it turns out that dates are stored in a different form on the classic than they are on the new form. So we're getting an error. Not because there's no date filled in, but because it's not in the format that's expected here. So we can fix that. Actually,
1025.
it's 10 and slash 25 slash was it 2, so 17.
Yeah.
Okay. So it likes that format of date. So 1154. We'll fix this one. 01/01. Now it likes that. It already liked the weight and height and calculated the BMI and put it over here and said and evaluated it, whether it was normal or not. And the retired administrative ethnicity level education all came in. And this was not answered, didn't come in. I forget whether it was answered on the previous form or not. But it's preventing us from going forward because that is not answered. So we'll answer it. And press next. And we'll go to the next form. The next tab of this form. So we could say yes or no. Let's say no. Then we should be able to go on to the next one, and we can. And this is the medical history. Now I'm not sure how much of this has to be filled in.
Only one way to find out.
But we're going to find out this way. Just press next and see what changed color.
Oh, it let us do it.
No, did it?
Yeah,
I guess yeah, we're on the smoking history. Now I bet we can't just press next on this one.
You might not have filled in the required fields yet for these tabs.
Yeah, that's possible.
Oh, there we go.
Yeah, we got smoked it all. No.
He wants us to fill in a date on that.
the date when I never smoked at all.
Yeah.
Yeah. So there's a couple. So it's still undergoing. Let's say yes, and January.
Try the first one. Have you smoked at least 100?
Oh, okay. Should I say yes or no?
Let's know as much as we can.
And then change into last month right by the cursor, yeah.
All right.
Hey. 94 years since we quit. Excellent.
Even though we never smoked. Anyway, we've got some internal logic things that have to be done that Dom's still working on. He told us, I don't know if he's on the call. He did tell us that this is work in progress. That it's not ready for prime time, but we're trying to get the interface between Vista and the form ready for prime time, so that as the form improves, we'll be able to actually test it and test the interface as well, and test. Ooh, there's a submit feedback. I wonder what happens.
That's fair.
Oh, sorry.
That's reasonable.
Oh yeah, that's feedback on the form. That's not submitting the form. It's all right. We don't have to submit the form yet.
Art just joined the call.
Oh, good. We can go back and visit any of these tabs.
So, Art, what's new and exciting this week is that we got a sneak peek of tying the new enhanced LCAP background form into Vista. So when he brought it up, it pre-populated with the Vista data.
Oh, very cool.
Well, it wasn't with Vista data. It was with the data that had been saved on the older copy of the form.
Exactly.
Right. But yeah, so if we go over, we can show them. Go back to the original form, and we have information stored here that's been saved and entered. And we go now just use the same form processor and go to the new form, and the data is pulled over. And we were just tabbing through. We have to fix the formats of the dates. because it thinks it doesn't like this. It doesn't accept this format at this point. That takes us to the next. Yes. Okay. The thing that yeah. So it's supposed to turn these fields on for us to fill in. We go to next. It goes to the next tab, which is smoking history.
Yeah, it looks like that still needs to get operational.
Yeah, and maybe it's operational in the standalone, but it's just not it's not working yet. Maybe the Vista, the form processor is interfering with it working. I mean, some of this might work standalone, so that we're gonna have to do some of that comparison to see if there's anything that might be interfering with in the form processing that would cause it not to work, or it might not work in the standalone. I'm not sure. So that's the big reveal for this week, is we have various concepts of maybe how to get to some of the other forms for this patient, and how to get back the home key. I don't know if that'll work. Yeah, so the navigation has to be worked on also. So any questions? We're looking forward to having the submit key or the save key implemented, so that we can begin to, do things like enter things on this form and then go back to the other form and see if they're saved. So we can do that kind of testing. So.
Awesome. Thanks, George.
You're welcome.
Okay. So, Rick, you about ready?
Sure. Why not?
Okay, cool.
So this is a topic that's been a long time coming. I'd say
you probably want to speak up or fix your microphone or something.
Oh, is my mic not working?
Yeah, we can't really hear you very well.
Uh-oh. Hang on.
For once, you're very quiet. Normally, you blow us out.
Let's fix that. Linda gave me her headphone, and I'll give her mine, although she doesn't like that particular model. So this is a topic that has been a long time coming. You could say it's
still have a hard time hearing you.
Oh, that's weird. So even though it's on, the audio's not coming through. Okay. I'm going to adjust my audio. Give me a second. Okay, how about now? Am I audible?
There you are.
Okay, so normally I'm using the splitter in the headset that Linda and them use. Let me mute this thing. But today I'm switching over to using my own headset off of my own laptop. It'll cause a little lag for Alexis and Linda, but That's all right. They can hear me. I'm sitting right here. So the MUMPS Advanced Shell. Well, yeah, let's mute a few of these things. Okay. MUMPS Advanced Shell is a topic that has been coming for a long time. Its roots go back to the 1980s when the MUMPS Development Committee, which is responsible for the development of the MUMPS standard language, or the MUMPS language standard, depending on how you want to express it, realized that it was not enough to be standardizing the syntax and the database behavior and the virtual machine and so forth, that there was a problem with the MUMPS architecture. And the problem was that because the MDC was focusing on the language, it sort of meant there was no place for common utilities that could be shared between different systems that were using MUMPS. We were back in that point. We were at a place where people were reinventing the wheel. If Epic wanted to have datetime libraries, they had to write their own. If Vista wanted datetime libraries, even if they were the same datetime libraries, they wrote their own. Everybody who was writing MUMPS software was reinventing the wheel when it came to standard libraries. In the Vista world, it led to the creation of a lot of software in the kernel application, and the FileMan application, in the broker, really everywhere. I mean, there were as we discovered when we did the Y2K conversion back in '99, there were datetime utilities scattered all over Vista. But even if the applications had been rigorously using the libraries that they were supposed to, we still wouldn't have had a clear place about where to put them. We put them in the kernel application for want of anywhere else to put them. But even so, when we did that, we were left with a condition in which some of our datetime libraries were in FileMan because they'd already been there before, and some of them were in kernel. The primary kernel developer back in those days was Wally Fort, although there was a whole team of us, including Joel, who's on this call, and me, who's on this call. And we sort of wrestled with this question of where do we want to put our standard utilities. And they ended up in a variety of places, mainly because there wasn't a clear home. There wasn't a separate application whose name was, this is where stuff goes that doesn't belong to any particular application, but that everybody might want to use. So at the same time that we were trying to solve that at the level of where to put it inside of Vista or Epic or what have you, the MUMPS Development Committee was working on a plan. That plan initially was far more modest than what we ultimately needed. And I'm going to take us to this first one. This is X1194-23, an extension to the MUMPS language that was passed in 1995. Or 94, somewhere in there, June 94 it looks like, called Library Proposal. And it was a way to extend the syntax of the MUMPS language so that there was a place in the language itself to put standard libraries like datetime conversions and so forth. And once we had this, then the MDC began pumping out proposal after proposal, extension after extension, to extend the language, like with matrix mathematics, to include standard types of things that anybody might want to do that's not particular to your application, it's not particular to your business, your enterprise, it's something everybody ought to have, but that also can't be justified as technically changing the language, except that they did it in a way that required changing the language. In the library mathematics library proposal extension to the language, they were introducing a new syntax, and the new syntax was $%. So if you wanted to access, for example, pi, then you would set a variable equal to $%pi up arrow math. Now, this was a very, for the era that they were back in, when they were thinking about their job as primarily being to modify the MUMPS language, that this was a typical way to do it. But in practice, it created a bottleneck, because it meant anytime you had an idea that was a standard kind of toolkit idea, you had to navigate the standards process. You couldn't just create it and add it to a standard library. You had to go, create an extension, a proposal, and blah blah blah. It was typical of its era. Now, these things got approved by the MDC, but the final standard that they were supposed to go into, the Millennium Standard, never got rolled. And so we're left with the 1995 MUMPS standard, which doesn't include these capabilities. But we're also left with all of these extensions, which were approved and are full of good stuff, but there's no logical place to put them. So after the MDC went into hibernation in 1999, a number of us who were actively involved in the task groups and working groups that continued functioning decided that actually, it had been a strategic mistake to say that we have to modify the language itself in order to add standard tools. We wanted to have a lighter weight, faster, more responsive way to add tools. So what we did was we came up with the idea of the months advanced shell. This emerged as a concept between 2007 and 2009. And people involved in this included David Wixell, it included Larry Landis, and a number of us who were working on this. And what we ultimately resolved to do is to create a working group of the MDC Reconstitution Task Group that would focus on what ought to be included in that library of tools that should be available on all MUMP systems. And they would write them like MUMP software, and they'd use a namespace to keep them out of the way of everybody else. But otherwise, we weren't going to modify the syntax of the language. We weren't changing the language itself. We were expanding the one way of seeing it is that we were taking an alternative approach to something we'd already been doing since the late 1980s. The other way to see it is that we were splitting the focus of the MDC to now handle two layers, not just the MUMPS language itself, but a new layer that didn't exist before of common tools written in MUMPS, readable in MUMPS, operating inside the MUMPS environment, but not part of Vista, not part of EPIC, not part of any of these MUMPS-based systems. It would be inserted in between as a new layer between MUMPS and these other systems to provide common capabilities that really, why should everybody be reinventing the wheel? One of the simplest ways to see this is to look at the onion diagram, which kind of shows the core architecture of Vista's infrastructure. And in it, you can see the innermost layers is the hardware. Of course, you don't want to be tied to hardware because hardware goes obsolete rapidly. So then we wrap it up with an operating system. But you don't really want to be tied to that either, because then you end up being tied to a particular version and blah, blah, blah. So we get the MUMPS virtual machine, whose great power is that it's a portability engine that hides what's going on in the operating system and the hardware. So we can write software against the MUMPS virtual machine and not have to care what's underneath. And that's how the VA surfed the hardware revolution and went from their PDPs to VAXs to alphas. They went to PCs. They could run on any hardware that MUMPS can run on because MUMPS hides those details. But this is the old version of the onion diagram. And I haven't made a new one yet. I could have made one for this presentation, but I was busy programming. But if I were going to make a new one, it would be, we need another blue layer to wrap the MUMPS virtual machine, because MASH introduces a new layer of portability. Because once you get outside of MASH, then you start getting into, well, how does Vista use the globals and routines? And how does File Manager allow us to do database operations? And how do kernel and the broker and HL7 sit on top of FileMan and provide basic infrastructure and extensible frameworks to all the rest of Vista, which is then very insulated from the internals. But the way this captures the history of the way it has been up until now, where if we wanted to add, say, matrix mathematics capabilities, if we wanted those in Vista, we'd have to write them in Vista, even though the MDC already wrote them in its library extension, and even though EPIC may already have them, and so forth. Where this captures the current situation in which we are baking in the reinvention of the wheel across all these enterprises. So MUMPS Advanced Shell solves this problem by inserting a new blue layer outside the MUMPS virtual machine that creates a layer of standard tools, a standard programmer interface, standard tools, standard, the web, standard tools for MWeb services, parsing XML, right? What does that have to do with MUMPS? What does it have to do with Vista? Well, what it has to do is that if you're going to write a modern MUMPS-based system, you probably want to be able to parse XML. I mean, JSON, graph stores, all these capabilities are neither specific to Vista nor specific to MUMPS. They belong in this layer, this MUMPS Advanced Shell layer that wraps up the MUMPS virtual machine and language and provides standard capabilities. So that's the theory behind the MUMPS Advanced Shell, why it exists. We've been working on it for a long time. You can either say that we started working on it in the 2007 to 2009 timeframe when we coined the term the MUMPS Advanced Shell, or you could say it goes back a lot longer than that, all the way to the wrestling that we've been doing, and Wally Fort did, and all the rest of us, with what is the best way to get standardized tools available. Our project, VA PALS, heavily depends upon standardized tools. Some of those already exist, but most of them didn't when we started this project. Or if they did, they existed in a form that we already knew was going to go into the MUMPS Advanced Shell or had already been put into it. The MUMPS Advanced Shell is supplying all the missing infrastructure that Vista doesn't have that we need for a web-based application. So, for example, the web server, which began as part of the virtual patient record project that came out of Salt Lake ISC and has been developed further by Sam Habiel and the OSEHRA community, ultimately is going to go into the MUMPS Advanced Shell because modern MUMPS-based systems need to be able to provide web services and talk to the web. If they can't do that, they're not dealing with the modern world. It needs to be there. It's not Vista-specific. Ergo, the recipe very easily says that goes into the MUMPS Advanced Shell. Likewise, the forms processor that George has been developing for us for this project, which you saw in action in the earlier part of this call, when he was able to switch from form to form, versions of the background form, and they were all able to access the same system and pre-populate with the data. That's another thing that is neither specific to the current MUMPS syntax nor specific to Vista. It's not even specific to the background form that he was showing. It's a general purpose capability for handling forms. And do you want to be able to handle forms in a modern web-based environment? You bet you do. So it goes into the MUMPS Advanced Shell, again, by this very simple recipe. So I'm going to step away from this diagram for a moment and talk a little bit about what this is and what some of the pieces are. So for our project, most of the parts of the MUMPS Advanced Shell that we're focusing on are either pre-existing pieces like the web server, or they're absolutely new things like the forms processor or the graph store, the ability to store a graph database inside of MUMPS. But conceptually, it includes a much larger area. We're not going to try to include all the ideas we have for the MUMPS Advanced Shell. Not even all the software that we have finished is going into this release for VA PALS. We're doing our restricted release that focuses on not overwhelming the VA with a whole bunch of new infrastructure and architecture and software that they would have to wrap their heads around. Because normally in the VA world, things are either an operating system upgrade, or they're a MUMPS implementation upgrade, or they're Vista. Those are like the only categories, right? And so as a result, if it's Vista, it has to go through the kernel installation and distribution system as the model for installing into a VA environment. If it's not, if it's just an upgrade to MUMPS or to the operating system, then they have separate methods of software distribution. But there's that split, right? There's the missing piece in the middle is, well, what about the MUMPS Advanced Shell? How would that be distributed to the VA? And the answer has to be that it is not Vista-specific, because that's the recipe. If it's Vista-specific, we don't put it in the MUMPS Advanced Shell. So since it's not Vista-specific, it doesn't make sense for it to be installed using the kernel installation and distribution system, which is a Vista application. It's a Vista module. It's Vista-aware. It does things in a Vista way. It needs to be done in a different way. And we're following the model that MUMPS has followed whenever it updates its own utilities, which is there's a routine save and there's a global save. And they're sent out as files. And if you want to drop them in, you load the global save, you load the routine save, and that installs them into the environment. This is the model we're basically following because what we're talking about here is something that's an extension of MUMPS to add general purpose capabilities. The total field of things that the MUMPS Advanced Shell will eventually deal with, I'll just take a moment to give some sense of the amount of planning that's going in. I've been working on this diagram and the associated lists for most of the last 10 years, off and on. So let's zoom in a little bit more and take a look. MUMPS uses an organizational model internally of the alphabet. So, and actually, let me jump to that for a sec first, just for comparison. This is a current draft of MUMPS 1995, the current MUMPS standard. And what you see here is one of MUMPS's alphabets. MUMPS has a number of alphabets. This is the alphabet of commands. We don't have an A command, but we do have B, C, D, E, F, and so forth. And we have a bunch of T commands, so there's multiple Ts. So it's an odd alphabet. But if you're a MUMPS programmer, you know this thing by heart. You just know these things. You've learned these. There's a similar alphabet for functions that are built into the language, like $length is L, and $find is F. And likewise, there's a couple more of those. There's one for structured system variables, and there's one for intrinsic special variables. But the point is, MUMPS's mnemonic schema is alphabets, right?
How does H and H not be separate? I mean, they're separate.
Well, that's what's so hilarious about mumps, is mumps has two different commands hiding under the same letter, right? So in mumps, it's not ambiguous because one of them is required to take an argument and the other one is prohibited from taking an argument. So you always know when you're looking at it in the code which one it is. But if I give you the, let me decline that. But if I just hand you H as part of the mumps command alphabet, one of the ambiguities of mumps is you don't know until you see it in context. It could be halt or hang. That's why I put it there twice, because it's a tricky one. Excellent question. So we decided to follow that same model, right? This is a mumpsy way of doing things. It gives us a mnemonic. We followed that same model for trying to organize the entire field of every area of computer science that could be considered a generic general purpose toolkit that we might want to add to mumps without changing its syntax. That includes an enormous area of possibilities, multiple generations of possibilities, which I've currently captured as 3 generations. There's 3rd generation concepts that have to do with tools for looking at globals, which is how we store data. Tools for manipulating files on the disk, in the operating system, right? Because mumps doesn't, for those who don't know mumps doesn't treat files as native to the language. It doesn't have commands that are about files, and it has an entirely different model. But yet still in the modern world, because mumps has to interact with the rest of the world, we have to be able to interact with files. So there are extensions for that. Mumps' code is stored in the form of routines, so of course there's a routines module. So some of this makes its way directly into the alphabet. For example, if we scroll over here, we see G is for global, right? And there's a little hub of capabilities around globals. R is for routine. These are things that might seem odd to someone who doesn't know mumps, but to a mumpster, of course G is for global, of course R is for routine. What else would they stand for? It's like there might be competing things, but these are so important, they're the obvious choices. And then down here, D is for devices, F is for files. There's a certain amount of mnemonic logic that goes on here that you can do for a while until you start to run into collisions. And sorting out the collisions and deciding which ideas are preeminent enough that they belong in the mumps library and which ones should be pushed down a level is one of those fiddly, horrible little details that nobody but me would want to spend the kind of time on that I've spent on over the years. But I have, so that you don't have to suffer. I did it for you. That's right. I suffered for your sins. So a bunch of these ideas will look familiar to people, but you'll see that in addition to kind of just laying out what the alphabet stands for off on the left, I've also color-coded them, because what I'm capturing here is what you might think of as multiple generations of programming languages. It's kind of my meta way of organizing where I put things. And it goes like this. First generation languages are assembly logic. I mean, it's not assembly logic, they're machine code. You are actually writing the machine codes the way that the chip understands it, and therefore your code can only run on that chip. That's your own, and you're having to speak it the way the chip understands it as numbers, right? It's horrible, which is why, although surprisingly it took decades for people to come up with assembly language, but it's why people came up with assembly language, is so that we replace those machine codes with alphanumeric mnemonics. So branch instead of 0010100 or whatever the hell it was, right? Store, add, assembly language introduces the idea of these mnemonics, and it introduces the idea of variable names. We no longer have to address the memory physically by where it is. We can say, I choose to call this location logarithm, and I'm going to put a logarithm in it, as you might infer from the name I chose for it. So that's second generation languages, but the problem with them is they're still tied to the chipset. Even though it's not horrible anymore for a human being to write these programming languages, they're completely non-portable. They're absolutely locked into that one chip, and the moment you change chips, there goes your software. For that reason, that is the reason why third generation programming languages exist. Mumps is a third generation programming languages. Almost every programming language that people can think of these days, they're third generation languages, including most of the ones that claim to be fourth generation, which, there is such a thing as the fourth generation, but most things that claim to be fourth generation, it's mostly a marketing ploy. So what is it that defines the third generation languages? I'm bringing this up because this will help you to understand what's in here and why. It's a third generation language if it is algorithmic, like the first and second generation languages are. That is, it says what to do in some fashion, whether by asking questions or by giving instructions or what have you. But it is not tied to a specific hardware. If it's tied to a specific hardware, it would be second generation, right? If it's tied to a chipset, it's second generation. You might think of second and a half generation in between as maybe it's not tied to a chipset, but it's still tied to too much about the hardware. But if it's truly independent of the hardware, like MUMPS is almost completely third generation. So what's a fourth generation language? It's looking ahead a little bit because that's going to be captured here as an idea. A fourth generation is a non-algorithmic language. It does not deal in storage locations and text and steps. It deals in context and meaning. It's what third generation languages can't do. In third generation languages, all we can do is put comments in to say, well, the reason I'm writing this is because I hope that this will successfully admit a patient to the hospital. But of course it might not. Right? That's the whole struggle at the third generation, is that there is no way to write a contract for a subroutine that says, and by the way, when the subroutine finishes running, the patient will be admitted to the hospital, because no third generation programming language knows what a patient is or what a hospital is or what admitting them could possibly mean. So instead, all of our contracts in third generation languages look like things like, you should put a string this long in this first argument, and you should put a number between these values in the second argument, and when we're done, this other storage location will have this thing in it, none of which actually means a patient has been admitted to a hospital. We just try to jury-rig, cobble together a bunch of pieces of algorithmic explanation that sort of substitute for the meaning that we intend to do. Fourth generation language would be able to say the patient has been admitted to the hospital. So for example, the psych language, CYC, which PsyCorp has been working on for decades, is an example of a fourth generation language. It can say things like, has the patient been admitted to the hospital, and express them in a way that's meaningful in terms of what it does. That's the future. In between that, we sort of have object-oriented, or would-be object-oriented programming languages, which try to reorganize the contents of the system in a way that makes sense according to the real world, except that they're doing it in a third generation way, which means there's nothing about the real world actually captured there. It's intuitive for us to have all of the patient-related software and data in one place, but the computer doesn't know that that's patient-related stuff. Only we know that, right? And so we can do it badly. We can do our object-oriented decomposition badly, and not only put patient-related stuff, we could also stick some doctor-related stuff and also some things about our car in there. And the computer will never say, no, that really doesn't belong there. That's not part of this. And still, when we write an object-oriented method that says, we could say patient.admit or hospital.admit patient or some similar object-oriented looking thing, but still, when you read the contract that defines how it behaves, it's still not going to say, I have admitted the patient to the hospital by the time this thing finishes running, because it's a third generation language. It doesn't know what a patient or a hospital or an admission would be. So true object-oriented languages will be sort of like generation 3.5. They'll have to stride the boundary so that the implementation that actually makes the patient get admitted into the system is written in a third generation language, but the contract that says what the subroutine does is written in a fourth generation language. To do true object orientation, you have to have both third generation and fourth generation. How do I know this stuff? Why is this relevant? Because the MDC had Subcommittee 16, which was working on object-oriented extensions to MUMPS. We were studying the state of the art in the late 90s and early 2000s. And let me tell you, it has not come very far since then. Progress in computer science is a lot slower than most consumers think it is. But the point is, when I was laying out where everything should go in the MUMPS Advanced Shell, I tried to not only look back to what we have created already and to what we've needed for a while, I tried to look ahead to where things are going to go. So there is a 3-level split. The blue stuff is all MUMPS level stuff. Things about routines, things about globals, things about files, things about data types, because data types don't belong in the places we put them in Vista. We just didn't have anywhere else to put them. The red layer, which I explicate more down here, which I call FileMan 24 concepts, that's not really what it is. This is object-oriented concepts. This is about classes and data sets and about protocols and queries and methods and properties, right? This is the stuff that we know we are moving into. People are already working with object-oriented extensions to MUMPS. And a lot of the systems that we talk to, like JavaScript or Java or whatever else we talk to as our other external languages that we have to be able to represent, they have object-oriented concepts. So if we don't have them, we have no future ahead of us. So I set aside space in the alphabet for critical things like class and set, which is data set, and so forth. But that's still not enough, because we already know what the fourth generation is going to look like, and we already know that our contracts are going to be inadequate. for our object-oriented stuff, unless they can at some point interface with a fourth-generation language like Scikor to say, the purpose of this subroutine is to admit a patient to the hospital, and by the time it's done, that will have happened, and have the computer be able to read that contract definition and say, okay, I will enforce that, and I will throw an error if by the time the subroutine is done, the patient has not been admitted to a hospital. That's what you want. That's the behavior that we're all after, is to get support from the system for the meaningful behavior. And so to support that, we have knowledge for representing ontologies, since O was taken by object, and language for having ways to express languages other than mumps and JavaScript and so forth, to be able to express human language concepts in a way that's tied back to an ontology. Interfaces and extensions, I think, are the group of 4 things, based on my understanding of Scikor and artificial intelligence, that we're absolutely going to have room for. So this is the top-level organization of the MUMPS Advanced Shell, which has been evolving very carefully over a very long time. And partially it's about reasoning it out, and partially it's about trying things and discovering where the problems are. So as a result, side by side with this, we have also been developing, where is it? Yes, this thing. Which, as you can see, the most recent update was December 18th, and the earliest update in here is back September 2009. I've been at this for a while, and in here, we've captured the MUMPS alphabet, but we've also broken it down into what are the different kinds of routines that we would make in each of these areas. For example, if we want to have support for files, what are examples of some of the operations you need to be able to do on files? What are the kinds of operations you have to do on devices? What do you have to do on classes? And so forth. And then in addition to routines, files. What's the data that we're storing? What has to be stored for us to be able to function as a system? And so this is refined a lot over just even the last 2 or 3 years, as we've been working on the VA PALS, and before that the Taskman 9 projects, which unveiled a lot of things that we need to know about, like we have to have a database of time zones to be able to do date-time manipulation. It has to be built right in. Right? If it's not built right in, then we can't do time zones accurately. If we can't do time zones accurately, why are we pretending to do a date-time library? So in this way, things get forced into the architecture of the MUMPS Advanced Shell as being requirements or implications of the larger structure that's going on. But it still comes down to the same thing. What is a general purpose tool set that we don't want to modify the MUMPS language in order to create it, but it also is not specific to Vista or Epic or any of these other systems. All right, so there's this, and we've been working on this for a while. Among the things that are in here is I'm going to drill down on 2 of the things that are most relevant for VA PALS to help you to understand where some of the code is that we're building and why it's there. So one of them is W is for write, and writing originally started as a concept for putting output, and it includes the idea of reading, because R is for routine, so we can't make R be for read. Reading and writing originally start out as terminal-based operations, but as we generalized them, we realized that eventually it also has to include screen-oriented forms, screen manipulation, which was the next generation that came after terminal, strict dialogue mode, but also the web. Ultimately is part of this. So W is for write. It's also for web. It's basically for how it's for your user interfaces. It's for how you interact with the user. So we're building modules inside of the %W namespace as part of the VA PALS project, which are places for where we do forms processing, for example, under %WF. Or if we're doing things that have to do with dialogue, so that help text can be different or could be translated into different languages, that's under %WD. Which is where we manage our dialogue with the user by having boilerplate and coined phrases and so forth. And the web itself, when the M web server moves in eventually out of the VPR namespace, it'll go under %WW for the web. So these are, when you look at what's going to show up in the public repository tomorrow, maybe? I'm so close. My goodness. I just keep being interrupted by meetings. Hi, guys. You will see that there are some %WF routines in there, and that means they're part of the MUMPS Advanced Shell, and that's why they're in this area that they're in, and some %WD routines in there as well. Another area that we're actively working on in the MUMPS Advanced Shell, I'm scrolling through all the data type stuff because we tried to avoid that with you guys, even though we have a huge amount of it for other projects, is formats. And this is part of the dataset module of the MUMPS Advanced Shell. The idea of datasets is that a data set is a way to store a collection of data, but it is independent of the format that's used, right? If you want to say what are the fields that are stored in here, you do that with a class. And if you want to say what the format is that it's stored in, that's under %SF, where we define lots and lots of different formats, including FileMan/Vista format, but also graph store formats, FIRE formats, CDA, you name it. Right, all of the things that seem like they're major areas in computer science today, we made an area in the sub-alphabet under %SF to create the utilities that are for manipulating that kind of thing. And this is where we write our format converters. We do an abstract data marshalling system that says if you want to convert from FileMan format to GraphStore format, we've got a converter for that. If you want to convert from GraphStore into the kind of JSON, we've got a converter for that. So all these converters go in here. And right now we call them directly, but eventually we're going to make an extensible framework that we'll plug those converters into, and it'll be entirely table-driven. You'll just call the converter, you'll call the data marshaller, you say, I'm going from this to that, and it'll find the converter that runs it, and it'll run it. Where this eventually leads later on is %I is for interfaces. So eventually you'll have interfaces between systems or users or devices, and associated with a device or a system or a user will be a set of formats. And so we'll know if I want to move data to the Cerner system, it'll be able to look up on the interface. Okay, I'm coming from Vista, so I'm probably in Vista format to begin with. I'm going to Cerner's blah, blah, blah interface, which expects JSON, or maybe it expects FIRE. So therefore, it can conclude by itself. You don't have to tell it, I want you to convert JSON to FIRE. It'll be able to figure it out just from the fact that you're going from Vista to Cerner. And the idea is to move further and further and further away from having to handcraft interfaces between systems, which makes up half of all activity within medical informatics today when it comes to computer science people working. It's a huge time sink right now the way it's done, and we're trying to build an architecture that can just get rid of that area so we can all go back to focusing on the medicine, which is the really important area, right? So you'll also see some routines that are in the %S namespace, because they have to do with data set operations. At this point, we haven't included any of the %C stuff for class definitions, but eventually that's going in there too. Because class definitions are where we do our specifications of what are the fields that are in this file. At present, we do that through an ad hoc graph store, but we've got data dictionaries for FileMan format as well, and those are relying upon FileMan to be the one who knows. But the problem is that we don't for this project we don't have control over the FileMan team or their development or their priorities. We don't have control over the kernel team. We don't have control over any of those guys. So instead we're writing this class-based thing as an extensible system, again, where you could plug in a module that explains FileMan format to it, so that it knows how to look up a FileMan definition of a field. So that's all coming. That's work that's ongoing. So this is a basic level introduction to the MUMPS Advanced Shell. It's obviously very rushed for something that's been going on for multiple decades, but I hope that it gives you some idea of why it is that we are not just releasing one application. There's a rule in Vista that says thou shalt not recreate infrastructure redundantly in multiple places. And that rule partly goes back to 1984 and before, when people first started creating FileMan in the kernel. But partly a bunch of it comes out of the Y2K conversion in 1998-99, when people said, for the love of God, could you stop writing date time conversion utilities? Because it just means that we have to go all over Vista hunting these things down and replacing them when they run into limits. We'd rather have our infrastructure in one place. But the problem is, for some infrastructure, there's a logical place, like the broker stuff goes in the broker applications. For other things, like date time utilities or forms processors or so forth, there is no logical place in Vista. And even if they were, we wouldn't have the permission to change it. So that's why we have to have the MUMPS Advanced Shell. It gives us a way to stop reinventing the wheel. And it gives us solutions that are done in a standard format. Everything that's being developed for VA PALS that has to do with the MUMPS Advanced Shell, just like the things that were done before for Taskman 9, that for the Kingdom of Jordan, that had to do with the MUMPS Advanced Shell, like our unit test software and our performance metrics and all that other stuff we wrote for that. It's all being written according to the MASH standards and conventions, the MUMPS standard pattern language that we're using. And it's all going to be submitted through Working Group 4 of Task Group 19 of the MDC to eventually become part of the standard, part of that new standard, the month's advanced shell. So I hope that gives you a little introduction. I wanted to leave a little bit of time at the end for questions. I have lots more slides, but I'm not going to show them today because I just wanted to give you guys a taste. So back to you, Linda.
Can you guys hear me?
Yeah.
Okay. Well, I don't know why they couldn't hear you on this headset. That's kind of weird. Anyways, sorry, I was daydreaming once Rick got to the part where it was like, okay, that's above my pay grade. Okay, so next we're going to keep working on the forms processor and the enhanced LCAP background form. Hopefully move to another form pretty soon because I think all of us are getting a little tired of the background form because that's where we started, where we're doing all of our experimenting. And it sounds like, does anybody have any questions or comments that they haven't shared with us yet? Okay, I'll take that as a no. So I think I can also assume then that we don't have any new business, which brings us to our next planned meeting, which as far as I know is next week, same time, same bat channel. So thank you very much, everyone.
Thanks, everyone. Take care.
Thank you.